Hi, it's Grant. So, in this last of this little first series that I'm making a kind of little overview thing, I want to talk about the more abstract pieces. If this isn't already abstract enough, I want to talk about the abstract piece that you might think of as a workflow. Now, professionally, what I do is called a modern term for it would be called data engineering. The idea is that you're taking a bunch of semi-structured or maybe very structured or whatever. You got some data, and you're going to take this thing and you're going to translate it sort of and make it into another kind of a thing, right? Where like you have let's back up. What is data, right? How do you think of data? It's stuff that's written down, maybe. It's, I would say, a good definition of data is information, but it's information in context. Um, Meaning just something sitting there by itself is, just a list of numbers doesn't necessarily mean anything. But a list of numbers saying, these are the numbers I played on the lotto this week or whatever. That puts it in context. All of a sudden, this stuff has meaning. So when you think about data, it's not just the thing that's there; it's the thing that tells you what this thing means. That stuff is called metadata. And if I do anything professionally, it is that I keep track of metadata and understand how things move around and how we not only do we store data, but how do we impart meaning to it. I think of it as a translation, kind of. And what often happens is, you have it in some semi-structured way, maybe in this case, maybe in an Excel file, and we're going to take something that's in an Excel file and put it into some other form, into this case, a database that we can look things up in. That's a little more, that's structured internally differently. It's all how do you model the data. We're going to take it from one data model, which is a series of many flat tables, so to speak, and we're going to put it into this big conglomerate data structure that we call a graph. And, so in data engineering, which is what this is now an exercise in, right? We've got some data that has been recorded. It means something. We're going to keep track of what it means and put it in a different form, thus translating it. In these endeavors, professionally and in hobby projects, which is, I guess, what this is, you have different ways of what I would think of as interacting with this process. Generally, all right. So you could just take. Let's say you have a spreadsheet and you want to make it into a different spreadsheet based on some other different thing, right? And you sit there and you copy and you paste some stuff and you write some stuff by hand and you move some things around, right? So that would be an entirely manual process. If you had to do that 100 times, then you probably wouldn't want to do that by hand 100 times. What you would probably want to do is develop a set of rules that says move it around like this, right? And then there's things, programming languages and so forth. That's what what programming languages are for, is to take something and do something, automatically based on a series of steps. So you define how, like what you want to do to it basically, and then bada boom, let it roll, right? Now, sometimes you only have to do this once. Sometimes, many times, and in those cases, hey, just do it manually. Who cares? Professionally, I work on projects that would have a kind of tick over, right? Like we do, something's done, and then we do it, and we kind of never do it again, right? Like it's like, okay, so we only do it once, right? Well, so what happens is you might call that in a situation where you're only ever going to do something once, and then you're going to hand the product off, and it doesn't really matter that there's not like a process to getting to it, and maybe you did it all manually. It doesn't matter. We might call that a static file, right? And in the static world, the thing that is produced, right, the end state of the thing, is not meant to be updated. We've only kind of done it once. You could say what is more common in my line of work is that we would have some preliminary version of the thing, right? And then we would refine it and refine it and refine it and refine it. And this would be done in a series of discrete steps. I would say this is iterative. We iterate through steps. And what's happening is we have an initial state, just like with the static, and then we have a process, a regularized process that we would run, and it would produce another set of the state. And then run it again, it produces another set. Run it again. The idea is that you can run it as many times as you need to update the thing and have it become refined, your end state, that it gets better. But each time is like you have to go in and say, I'm going to update this thing. Now, there's a third type of thing, which I would call constant, which is what you have on something like an e-commerce website or something like that, or some customer service type thing where you have to interact with something in a real-time manner, right? The recommendation engine in Netflix or any recommendation engine, though that uses a graph. In fact, that is one of the primary applications for graph technology. But that recommendation engine is running that algorithm right then, right? Like when you're scrolling through your Netflix, where it says you might like yada yada yada. Well, that is that's like a real time system. That's like that like whenever I choose something, that goes right into the thing, and then the next person, it's slightly better. I mean, like they may do it in batches. I don't know, but financial things certainly must be real time, right? Because you can't have it just can't be off, right? You have to understand whether something's in somebody's bank account or whatever, like credit cards and things like that. They have to check up on stuff constantly. See, constant, right? So constant has a whole other set of things that go along with it, and it is there's a framework that would sort of be attached to that. It would probably be like always embedded in a website or whatever, and this thing is the user interacting with it on the other end of some website does something, and this thing, without me being involved, me being the developer, without me being involved, this thing sort of updates itself. There are some systems like that for, like I said, many good reasons to have things like that. My thought is, and that in some ways that's a good end state to go for. My personal preference is for this middle state, for the iterative. I'm biased because that is generally how it's done and how I have done it professionally. But also, it is, to me, I like having these discrete steps. I like having the breaks in between things to be able to consider them, because in a constant stream of stuff, when something gets gummed up, there's a whole other. It becomes more about maintaining the integrity of something running constantly than it does what are you actually thinking about. I like to be able to redesign this thing on the fly if I need to, right? I make decisions about, I want to change such and such. Well, I want the time to consider that decision and put off saying I'm going to make the next iteration of it until I feel like I've considered whatever it is that's in consideration. So I feel that leads to the best product because my time is spent thinking about the design of thing instead of how do I get this constant, infinite thing to work. At the same time, the constant data set is kind of a black box. You don't really have control over it, whereas the iterative step, you control each iteration. And if you don't like them, you can throw them out. Because ultimately, I'm not working directly on the thing that is behind in the website or whatever. I am working with sort of 2 or 3 levels back, and then I can push it out when I'm to some public place or whatever when I'm done. But I can iterate through it as many times as I want. Now, working iteratively does sort of almost demand that you do as much as possible programmatically. I can tell you that like having an iterative process that involves doing things by hand is well, from a professional standpoint, it's super goddamn annoying. I'll tell you that. If you say, hey, I need to do something maybe many times, and every time I do it, I gotta do some intricate hand manual maneuver, and like copy paste something from some document to some other document, and it's annoying as hell because one, monkey work, right? Like, but on the other hand, it's like, it's you're gonna make a mistake, right? Like you can't depend on your own hands to make that, like, you know to do the same thing every time, to guarantee that you're going to do the same hand maneuvers every single time. It's just not reliable in the long run, and it shouldn't be. Like, that we have computer languages so that you don't have to. So, given that that's kind of what it is. It's like we'll use a computer program or a series of computer programs that would run in a specific order that would do everything that we need to do, no matter how complicated, between each step. And as it moves through the process, as the data set gets more and more refined, we're still running the same series of processes over and over again. And what we're refining is the thing that says, here's the rule set. And that's programming. That's basically all programming is in the first place. Certainly, this sort of thing, data processing. So my last little slide here before I move out of this deck is I've got sort of a rough list of like the stuff that is involved in maybe any intermediate step. Some of these things are things that kind of get done once, and then and then they become they become a piece of the ongoing process, but not necessarily that I'm doing everything that I'm going to do to them every time. The best example of this is the parsing of the corpus. We have if I have some let's see, in its rawest form. Here's a Clash of Kings. It just looks like this. It's just a text file. This is only very semi-structured data. It's all words and stuff. I know what it is, but it doesn't really tell me like. It's just the whole raw text. These lines don't mean anything. These page numbers are in here, junk like that. Excuse me. What I have done by hand, when I mentioned that I make hand changes to these, is I added in these titles above each chapter to say what the title of the chapter is and who the POV is, and then it can kind of do all the rest as it counts itself up. I don't have to give it any more information like that because I can I can determine the information that I need basically based on the patterns that I find, but I do have to do this minimal amount. So anyway, this whole process of let's take this raw thing and parse it doesn't have to happen every time. I only really kind of have to do it once and get it right and have it feed itself into a way that holds it for the next piece, which would be to hold it in Excel. And in fact, here is that corpus with that's just line by line and all indexed and stuff. So the whole first step would be, let's take this raw text and turn it into this pretty organized version of the same thing, but that has all this indexing to it and this extra layer of data. And so because I'm putting it in a thing like this, I want to have all of my data in something like this. So for something else that's like the list of characters, I'm also going to put it in a table. And I'm going to furthermore mark it up to tell my process and to record for myself how to treat the different pieces of data. For example, this little notation here tells me that in this table, all of these things are characters, are meant to be a node of type character, and that furthermore that I need this list to be unique. And that's kind of the information that the starting information that the computer program might need in order to take this thing and move it into the database, which is the next step. So when I say that I'm normalizing and marking up, what it means is that I'm making a series of sheets that bear basically the same structure to them and are using this common markup language to tell me how I want to treat them going forward. Okay, so then we have Python program that takes that data and through interfacing with both this Excel file and the database structure, that it would transfer it into the Neo4j database, which is this right here. I mean, I'm not going to get into what all this is doing, but this is the program that reads that database directly. You can see I have 230,000 nodes in there right now, 231,000, 54 different kinds, and about 2.5 million relationships right now, of 46 different kinds of those. And we can look directly in the thing using this little application. We could see something like the character model, and see these are all nodes, right? One-eyed. Okay, so here's part of the model nodes, one-eyed, just the concept of being one-eyed, and here are some character nodes of people who have the trait of one-eyed, right? So if we go back here and we say, where are these traits? Okay, we could say sort this. One-eyed. Oh, that's okay. Interesting. Ah, no. Okay, so here's a one-eyed person with this trait, and that's Euron Greyjoy. So indeed, we find that Euron Greyjoy has the trait one-eyed, right? So there's I have a relatively few Python programs that are doing this. You can see I have parse the raw data. I have clean the corpus, which is some maintenance that I'm doing on the corpus because the input of parse raw isn't perfect, and so this is kind of an intermediate program to sort of grease the wheels. And then this program here, make GRROM, it takes that data and those things and turns it into this. And so back to the preparation steps. Now we've parsed the corpus into an Excel file. We've taken several Excel files and made them the same, including the one that we parsed. Then we have a thing that puts all of that stuff into that database. And then we have what I would think of as, this is the whole first part of the preparation step. This is the first half, and then the rest of this is, let's do stuff with the things that with this thing that we made. Now that we have this structure, it's all well and good to have this thing, but honestly, like, poking through it like this is only marginally useful. Like, it's sort of interesting because you can just sort of explore it, but there's there's different programs that do things like this in a different way. This is sort of a browser that's native with the database, but this is not how you'd actually use it. What you actually sort of want is, potentially several things. Sometimes what you want is maybe a spreadsheet, but a different kind of spreadsheet, right? Maybe you're just looking for some reported data. So that's when. So we want to have something that will take that raw database containing hundreds of thousands of nodes and millions of connections, and save out just the things that you want. Maybe as a table, but it's easier to get to because you have, there's, for all the computer science reasons of why this database is faster than and better connected than some sort of tabular database, consider how quickly I just found all the one-eyed people and what I could do when I say, just give me the thing that has trait one-eyed, right? And it would give me this list of things. Or give me the thing that has trait senile, and it would be these guys. And if you just want that list, that's a lot easier than even going into and having an Excel file like this or some other database like this, going through and sorting the thing and then trying to find it and then copying it. And so the idea is, how can we get to the information that we want as quickly as possible? There are, so I have sort of two different ways that I think about this. One way is there are just programmatic outputs, like a program like this where I can, where I've got different things that I can do with it, right? I can feed it in different inputs. I can say, go find me a quote, or I can say, give me a list of characters that meet some yada yada yada, or whatever, and it would spit me out a text file or a spreadsheet or whatever I ask it to. I can program things to have direct outputs. The other, let's say the public-facing one, would be this website form. Where I've had basically there's a copy of the database sitting in the root of this thing, if you like, and I can I can search for things. I can search for, well, let's see, search for dragon. Whoops, dragon. Okay, so there's going to be a lot of them. And look, see, this is a representation of what's called a subgraph. This isn't in a very good form. This is just to make sure that this is working. Like everything you see on this website is preliminary. But the idea is that that in searching for dragon, we have found all of these terms. This is mostly just mentions in the text. But I can look on here and say, of the types of nodes that I've got, is a dragon. I've also got capital D dragon. Those are Lex words that were associated with this. Here's some houses that are associated with dragons, and in other words, they have a dragon basically in as their sigil. Toland, Targaryen, Blackfire, and then a character, the last dragon, who literally has dragon in the name, and then some characters who actually are dragons, Viserion and Rhaegal and Drogon, and then many hundreds and hundreds and hundreds of fragments of pieces of text, over 1,000 mentions in the text of dragon, and that's across basically everything except Fire and Blood is in this particular version of it right now. I have parsed Fire and Blood, but it's not in here right now. Anyway, so we can, that this is powered by that thing, and the idea with this is that not only are there, they're this sort of tabular form or a weird looking, dot and line diagram that can, that is more just kind of pretty, I guess, than anything. But the idea, the end goal would be to have different data visualizations using, more or less, there are browser tools that are meant for making complex data, arbitrarily complex data visualizations based on straight into the browser, straight out of data that's in this thing. So the last step in the process, which I've done only a very little bit, that's not all that I've done, but You know, that's something that that is still nascent as far as this whole process goes. That would be data visualizations, and based on that, there would be call upable, right? So if it's that there is a particular type of data visualization that works well for, say, characters, or for comparing two characters or something, that itself might be a function on the website. And you'd say, call this function character 1, character 2, and then it would do some however elaborate thing it needed to do in order to do this comparison, pulling out the relevant data as it does, making the subgraph, which would be, you know, all of the nodes that are actually, you know, mentioned. Let's look at frog. There's two different types of things there. See, and this doesn't have everything in it because frog should have, like, ideally, in the ideal state, frog would give us the, would not be known to be the alias of Quentin Martell, and he would have come up as a character. But the idea is that when that happens, you might have there might be different ways of expressing it that give you different things. Maybe here it is in the context of the text, or here it is in the context of the timeline, or you know, different things like that. So that's basically it. I think I've kind of rambled on enough about this and shown those few examples, but I mean that's basically what, like, that's the whole gamut of stuff, right? And I know this is actually quite a lot of stuff because each one of these steps is a totally different thing. But in a data engineering sense, you've got to have all of these things. You've got to be able to parse your thing automatically. You've got to be able to mark it up automatically. Or at least in a harness, you know, like have it a harness for doing so that you're not doing things just by hand. It may be that you know, in here's the alias, right? Let's see, let's find Quentin Ball. Oh, where the hell is Quentin Martell? Oh, that's weird. Oh, okay. There it is. It just wasn't there. Frog. It is in there. How is that not? How did that not come up? Because okay, I know why. It's because, yeah, I have this set to be just these aliases are set to be a property instead of actually being connected to the lexing. Okay, well, that's something that needs to change. Anyway, that's a great example of why this is iterative, because the thing that says I want to tie this column to what ultimately comes up in this database to say that here it is, that this word frog in this table in this Excel file talking about the corpus with the words that it finds everywhere, that we've got the word frog. That word frog is going to become a node, and then in this source file, I want it to read this property, or this piece here, to say that frog is associated with Quentin Martell. The way I would do that is in this program that is the piece where it's doing that translation, and I've got a little bit down here that reads functions where I say I want to tie something to that list of words, right? So everything that's in every fragment, character, location, house index, house sigil, house words. So the character IDX would be the character name. So we want this to be character alias. And now, next time I run this thing, the character's alias will show up as a connection. That's what I mean by iterative. I didn't go in there and do anything by hand. I didn't even change it because it was already done. I just had never tied them together. So when I run this thing, it's sometimes I run the whole thing start to finish and say I'm going to recreate the entire thing, and that like can take hours and hours and hours to process, but not that long. But then but then some other times I'll do something that says, okay, everything that's in there right now is okay, and so what I'm going to do is kind of put something on top of it and let it run. It'll run much faster, make some changes. The kind of the rule of thumb is if I find I'm going to be deleting stuff that's in there, then oftentimes I'll just throw the whole thing away and recreate it from scratch, because I have written this thing as a series of programs instead of doing a bunch of shit by hand. I can do that because this is iterative. Okay, so I'm going to put this away for now, and I'm going to, I'll come back with something else, and what I'll do is I'll take some like a piece of the early step or whatever, and I'll start to do the deep dives into each piece of the methodology. So next is probably actually parsing, is probably just going to be about parsing, and to say let's take some text and put it into something that something that is a little more organized than just text, and some of the things that go along with that. But I think that's it for now.